Very good morning, dear students, and welcome to today's mathematics class. Today we will continue with chapter number 13, that is section and midpoint formula. And today we will carry this chapter further with midpoint formula. But before this, first we revise what is the section formula. So section formula, as we already discussed in the previous assignment, that section formula gives us the coordinate of a point P which divides the join of 2 points x1 y1 and x2 y2 in the ratio m1 ratio m2, and the coordinates of P are given by m1 x2 plus m2 x1 over m1 plus m2 and m1 y2 plus m2 y1 over m1 plus m2. So if we further extend this to the midpoint formula. What is midpoint? Midpoint is a point which lies exactly midway between A and B. That means the ratio is 1:1. So if we substitute the values of m1, m2 both equal to 1 in the section formula at the place of m1, m2 everywhere where it occurs, if we write their values as 1, then we get the midpoint of line segment AB, whose coordinates and points x1 y1, x2 y2. Then the midpoint will become x1 plus x2 over 2 and y1 plus y2 over 2. So therefore we can say that midpoint of the join of A, x1 y1 and B, x2 y2 is given by x1 plus x2 over 2 and y1 plus y2 over 2. So this is the midpoint of a line segment. So once again, midpoint of the join of A x1 y1 and B x2 y2 is given by x1 plus x2 over 2 and y1 plus y2 over 2. Now we extend the concept of midpoint to centroid of a triangle. So first of all, the centroid of a triangle means is the point of concurrency of all the medians. And point of concurrency means if 3 or more lines pass through a same point, then these lines are called concurrent lines, and the point through which they pass is called point of concurrency. So medians of a triangle, there are 3 medians and they all pass through a same point. So therefore the point of concurrency of the medians of a triangle is called centroid of a triangle. And centroid of a triangle divide each median in the ratio 2:1. And note one thing, that median of a triangle is the line segment joining vertex to the midpoint of opposite side. So here we will derive one formula for the coordinates of centroid of a triangle when all the vertices are given. So for this we consider a triangle ABC in which the coordinates of A, B and C are x1 y1, x2 y2, x3 y3, and AD is a median. It means D is midpoint of BC. So using midpoint formula we can find the coordinates of D. It is x2 plus x3 over 2 and y2 plus y3 over 2. So because D is midpoint, so therefore the coordinates of D are the coordinates of midpoint of BC by applying midpoint formula. Now we assume G as the centroid of triangle. So if we consider G as the centroid of triangle, then it divides AD in 2:1. And then by applying the section formula, m1 x2 plus m1 x1 over m1 plus m2. So here m1 is 2, x2 is x2 plus x3 over 2, and similarly for y coordinate. And by simplifying we get it as x1 plus x2 plus x3 because 2 cancel in both the cases of x and y, and we get with numerator as x1 plus x2 plus x3, and for y, y1 plus y2 plus y3, and denominator in each case is 3. So finally we get the result. The coordinates of centroid of triangle ABC having vertices A x1 y1, B x2 y2 and C x3 y3 are given by x1 plus x2 plus x3 over 3, y1 plus y2 plus y3 over 3. Means simply we get the coordinates of centroid by adding all the x coordinate, divide by 3, and for y coordinate all the y coordinates of the vertices and divide it by 3. Now we take a few problems from exercise 13b. So first a simple sum. First question, first part. Here the statement is find the midpoint of the line segment joining the points. First part is a minus 6, 7 and b 3, 5. So here x1 is minus 6, y1 is 7, x2 is 3, y2 is 5. So we know the midpoint formula. Midpoint of a line segment joining a point, joining the 2 points a x1 y1 and b x2 y2 are given by x1 plus x2 over 2, y1 plus y2 over 2. So by substituting the values of x1, x2, y1, y2, we get midpoints of AB as minus 6 plus 3 over 2, 7 plus 5 over 2, minus 3 by 2, 12 by 2. So it is minus 3 by 2, 6. So simple application. Sometimes it may happen that we are given with the midpoint and vertex coordinates of one end. So we can find the coordinates of other end. As in the question number 2. Here the statement is points A and B have coordinates 3, 5 and xy respectively. The midpoint of AB is 2, 3. Find the values of x and y. So here we are given with coordinates of one end, midpoint, and we need to find the coordinates of other end in terms of x and y. So here again we can use midpoint formula. Here x1 is 3, y1 is 5, x2 is x, y2 is y, and using midpoint formula we get x1 plus x2 over 2, y1 plus y2 over 2 is equal to 2 by 3. Put the values. x1 is 3, x2 is x, y1 is 5, y2 is y, and equate the corresponding coordinates. X coordinate with x coordinate both sides and y coordinate with y coordinate both sides. 3 plus x over 2 is 2, 5 plus y over 2 is equal to 3. Now simplify, we get 3 plus x is equal to 2 into 2 by cross multiplying. So x is 4 minus 3, x is equal to 1. 5 plus y, 3 into 2, that is 6. And shift 5 to the right hand side. So y is equal to 6 minus 5, that is 1. So therefore x is equal to 1 and y is also equal to 1. Now there are other applications of midpoint formula and centroid of a triangle in various cases. There is one case where is the case of a parallelogram in which 3 vertices of a parallelogram are given and we have to find the 4th vertex. And here we will use the result when the diagonals of a parallelogram intersects, they bisect each other, means the point where they intersect. Here if we write this point as M, then M is the midpoint of both AC and BD, because in a parallelogram the diagonals always bisects each other. So here we are given with the vertices A, B and D. The statement of question is A, B and D are the vertices of a parallelogram ABCD. Find the coordinates of vertex C. So we assume the coordinates of vertex C as XY. And we will use the result diagonal of parallelogram bisects each other. So it means midpoint of AC is equal to midpoint of BD. Apply midpoint formula on both the sides. For AC, it is minus 1 plus x over 2 and 0 plus y over 2. For BD, it is 1 plus 3 over 2 and 3 plus 5 over 2. Simplify right hand side and left hand side. 0 plus y is y, 1 plus 3 is 4, 4 over 2 is 2, 3 plus 5 is 8, 8 over 2 is 4. Now equate corresponding coordinates. X coordinate of both sides equal and y coordinates of both sides are also equal. So minus 1 plus x over 2 is equal to 2 and y over 2 is equal to 4. Now simplify. Minus 1 plus x, cross multiply 2 into 2, 4. 4 plus 1, shift minus 1 to right hand side. So x is equal to 5. And y over 2 is 4, so y is equal to 4 into 2. So y is equal to 8. So therefore the coordinates of the missing vertex, that is C, are 5 and 8. Students, let us consider one more problem from exercise 13b. In this case, we are given with the midpoints, the coordinates of midpoints of a triangle, and we need to find the vertices. So the statement is the points 2, -1, -1, 4 and -2, 2 are the midpoints of the sides of a triangle. Find its vertices. So we can give the name to the triangle ABC, and the vertices we can assume as A x1 y1, B x2 y2 and C x3 y3. And midpoints of sides AB, BC and CA are D, E and F respectively. Then using the midpoint formula, coordinate of D first. The coordinate of D, 2, -1. So it is x1 plus x2 over 2, y1 plus y2 over 2 by using the midpoint formula. Then equating both sides, x1 plus x2 over 2 is 2, y1 plus y2 over 2 is equal to -1. Then cross multiply, x1 plus x2 is 4, y1 plus y2 is -2. We can give these as equation number 1 and equation number 2. So from here you can get the idea that x1 plus x2 is double of 2, y1 plus y2 is double of -1. So similarly for other sides BC and CA, we can obtain the equations as, for BC, x2 plus x3 is double of -1, x2 plus x3 -2 and y2 plus y3 is double of 4, that is 8. And similarly for CA, x3 plus x1 is double of -2, that is -4, and y3 plus y1 is double of 2, that is 4. So we can write the other two sets of equation, and we can numbering the equations as 1, 2, 3, 4, 5 and 6. Now you can see 1, 3 and 5 equation number, they involve x coordinate. 2, 4 and 6, these equations involve y coordinates. So first we solve the set of equations 1, 3 and 5 in order to find x1, x2, x3. There are various methods to calculate the values of x1, x2, x3. Here I am using this one. First we add all the three equations 1, 3 and 5. You can see in all the three equations x1 occur 2 times, x2 2 times, x3 2 times. So it is twice x1 plus x2 plus x3. And when we add right hand side, 4 minus 2 minus 4, minus 4 minus 4 cancel, it is -2. So divide by 2, shift 2 to the right hand side. So it is x1 plus x2 plus x3 is equal to -1. And name this as equation number 7. Now by using 1, 3, 5 and 7, first we subtract 7, equation number 1 from 7. If we subtract equation 1 from 7, what we get? x1 plus x2 plus x3 minus x1 plus x2. x1, x2 cancel, left with x3. Right hand side -1 minus 4, it is -5. Similarly subtract 3 from 7, you will get x1 as 1, and subtract 5 from 7, you get x2 is equal to 3. And the same procedure we apply to the set of equation 2, 4 and 6. Again the same thing, y1, y2, y3, they occur 2 times. So therefore we add equation number 2, 4, 6 to get y1 plus y2 plus y3 is equal to 5. And then we subtract 2 from 8, 4 from 8, 6 from 8 to get the values of y3, y1 and y2. Then by combining all the things x1, x2, x3, y1, y2, y3, we get the coordinates of the vertices as A 1, -3, B 3, 1 and C -5, 7. Thank you very much students for watching this AV.